Hello everyone and welcome to 30 Days of Java. It's day 23 now and today we'll discuss about Lambda expressions in Java. In this video, we'll look into the concept of functional interfaces and Lambda expressions, exploring their significance and the reason behind their necessity. Let's get started. As we already know, an interface is like a contract which forces the class that implements it to define those methods. A functional interface is an interface that contains only one abstract method. It can contain multiple default or static methods, but there would only be a single abstract method present in it. We usually apply the @functional interface decorator to denote a functional interface in Java, which forces the interface to only have a single abstract method. Lambda expressions were introduced in Java 8 as a way to provide a concise syntax for implementing functional interfaces. They allow you to treat functionality as a method argument or to create anonymous functions. Lambda expressions are particularly useful in scenarios where you need to pass a behavior as an argument to a method, such as in streams, event handling, or concurrency. Let's now implement it on IntelliJ to better understand them. In IntelliJ, we already have a few files already set up, like this interface animal.java. This interface contains only one abstract method, that is makeSound. But for now, this interface can also contain other abstract methods. Why? Because we haven't declared it as a functional interface. So to declare it as a functional interface, we'll need to add a decorator here. We'll simply type in @functional interface, and that's it. If I try to add any other abstract method to this interface, like void eat, it would give me a compile time error. If I hover over it, you can see it's saying multiple non-overriding abstract methods found in interface animal. But if I make this abstract method into a default one by typing in default and giving it a definition like out eating, you can see it works fine without any issues. For now, we'll remove this. Now that we have a functional interface, let's create a class that implements this interface. So for that, we'll go to src, click on new, and then select Java class. Now we'll name this class as cat. Now this class would be implementing the interface animal. So we'll simply type in implements animal, and we'll need to define the method mentioned in the animal interface. So we'll hover over it and click on implement methods. We'll select makeSound and then click on OK. Now for its definition, we'll simply give it the sound of a cat, that is meow. Now to use this class in our first program.java, we'll need to instantiate it first. So we'll create the object here, cat equals to new cat. Now if I want to call the makeSound method, I can simply type in cat.makeSound. Now if I run this program, you can see it printed out meow in the console. Now let's take a different approach with this. Let's create another static method here, static void sound, which takes in an argument animal. So this takes in an object as an argument which implements the animal interface. And here I can simply type in animal.makeSound. Now if I want to use the cat object in it, I can simply type in sound and then pass in the cat object. Now I can comment this out, and if I run this, you can see it's still printed out meow in the console. This is happening because cat object already implements the animal interface. And since that animal interface has a method makeSound, which is also implemented by cat class, it works without any issues. Now the problem with this approach is that it's quite lengthy to write this code. First, we had to create a class called cat, which implements the method that was defined in the interface animal. Then we had to instantiate an object of cat class, that is cat in lowercase. Then we had to call the makeSound method on the cat object, or we had to call the sound method based on the cat object. So the same process can be implemented in a concise manner by the use of Lambda expressions. Now with the use of Lambda expressions, instead of passing the cat object itself here, we'll only be passing the definition of makeSound method. So if I copy the makeSound method definition from here and then paste it here in the sound function, so for now it's giving me some compile time errors. That's because the syntax for writing a Lambda expression is a little bit different than what we use for a simple function. So a couple of things to remember while writing a Lambda expression is that a Lambda expression doesn't need any access modifier. So we can remove this. Then it also doesn't need any return type. The Java compiler automatically detects the return type of this function. So we can remove that here. And we also don't need the name of the method. So I can remove that also. Now one more thing we need to add here is that we'll need to add the arrow operator. And that's it. That's your Lambda expression. The parenthesis here denotes the number of arguments that the function would take. Then the code inside the curly braces define the logic of the function. Since we only have a single line of logic for this function, I can even remove this curly braces. And also remove this terminator, and it works without any issue. So if I run this, you can see it still prints out meow. With the use of Lambda expression, you only pass the definition of the method makeSound instead of passing the whole object. Now I can also use some parameters with this Lambda expression. For using them, I first need to define them in the interface. In this makeSound, I'll simply type in an argument that is string food. Now if I go back to my first program, so first I need to pass in an argument here as well in the Lambda expression. I can use the same name for this, or I can simply call it by a different name, say f. Now I can add it here, and also need to make changes here in the sound method. So I'll simply change the definition of it. Now if I run this program, you can see it printed out meow space tuna. So this is how you can use an argument with a Lambda expression. One thing to note here is that when using a single argument, you can remove this parenthesis. So I can remove them and it would work fine. But if you are not using any arguments, or if you are using more than one argument, then you need to put in parenthesis here. And those arguments would be comma separated. So they would look something like this. Also, while passing the arguments, you don't need to specify their data types here, because those are already defined in the interface here. If you have a multi-line definition for your Lambda expression, then you can enclose that inside curly braces. and then write them like this. So I can type in here something like and if I run this program, it prints out both of those lines. Another thing to note here is that you can assign this function definition to an object. So I can write it something like this: animal equals to, and then copy this definition and write it here. And instead of passing the definition to the sound method, we can simply type in animal object. Now if I run this program, it would work the same, because again we are only sending out the definition. So this is how Lambda expression works in Java. They are used heavily in production environment in various places like delegates, link queue, or Java Stream API. In upcoming videos, we'll also be using them. As always, we'll end this video with a quote that says, "The soul becomes dyed with the color of its thought." Thank you for watching and have a great day.